Welcome all for this Spark training from Edureka. This is going to be very interesting training because we are going to discuss about Apache Spark, and that too we are going to see it with respect to one of our use case. Nothing can be best other than learning technology by understanding a use case. That is what we are going to do in this particular session. Moving further, so what you can expect from this session? There will be a use case of real-time analytics. What is real-time analytics? We will see multiple examples of it. Movie recommendation systems using Spark. How movie recommendation engines, you might be seeing IMDb, all these apps are using this Spark. How they are using it, why they are using it, what is Apache Spark? Getting the movie data set, because we are going to use a movie data set for it. We will be using it with Spark streaming, because by Spark streaming we can get the data set and the real-time data. We will be performing a machine learning, which will be collaborative filtering algorithm. Again, we will be applying machine learning MLlib part, and we will be fetching the result in the end and then storing it back. So that would be our agenda for today. So let's see some use cases of real-time analytics. We can talk about government agencies. Now, it's very important. You must be hearing about RAW, NIA, all those big agencies, right? So what they do, for them it's very important that they keep on performing the real-time analytics and kind of observe if any unusual activity can happen, right? Especially in military and all, it is very, very crucial. They cannot just wait for a long time. They cannot do kind of wait and then kind of pass the message. As soon as any unusual activity happens, they want to immediately pass on a broadcast message to all the maybe nearby, all the army or maybe police, everywhere they want to do that in order to ensure that there should be no threat for the country, right? So that is one example of use case. Let's see a few more. If we talk about medical domains, again, here it's very important. Now, maybe a patient is very critical and he require blood. Now, do you think he may be able to like sit for long? Maybe they will be able to wait for long and get the blood later? No. They have to kind of have a real-time system where they can immediately broadcast this message to all the blood bank from where they can get it. And that's how they should be getting the request back immediately, right? Request and response back should be immediate in this case. In terms of emergencies, it's very important because again, it's a scenario of life and death, right? They cannot take the risk by just kind of waiting for a long time. So here, the real-time analytics is really important. Similarly, where the companies who are kind of involved in calls, video chat, streaming, like you may be using, let's say Skype, Zoom, a lot of like softwares are available, right? So these companies are using real-time analytics to kind of do a lot of analytics and see that where the jitter happening, where the delay is happening, all those measurements they are doing with the help of real-time analytics. Banking transactions. This is very crucial. Now, in this case, you must be doing some transaction, immediately you get a message, right? So it's a real-time event what has happened. Because it's not like they are waiting for a long time, doing the processing and then giving back the result. No. As soon as you did something, immediately you are getting back the results. So that is, in bank, it's very important. Not only this, even they have to ensure that they should not be losing any data, because we are working on a network. It can happen that due to a network failure, the message have not reached you or any update have not happened in the bank side. So they cannot afford all that. And these all things are possible with the help of real-time analytics. Top marketing. You might have heard some big names like Goldman Sachs, Tower Research. Even there are other companies like Rethinks and all. Right? They have developed a smart algorithm where they have designed a real-time system which kind of predict, okay, this share is going to go down, this share is going to go up, because accordingly they can treat other customer shares. They can either sell it, they can either buy it, and based on that, they are actually making a good profit. Right? So all these companies are also using real-time analytics. Let's understand one movie recommendation engine. So you can see so many movies in front of you. Now let's design a movie recommendation engine. What is movie recommendation engine? A movie recommendation, you must have seen IMDb, right? So what you generally do when you want to see that movie is good or bad, you generally go to your IMDb, see the rating, and then based on that, you kind of decide, okay, should I watch this or should I not watch this, right? A lot of time you must have done that. Now, we want to design a movie recommendation engine where we want to build something like, let's say if you are liking this movie, A, B, and C movie, what are the other likely movies you are going to like? How we are going to design all that? With the help of other user record. Because maybe if you are liking ABC movie, if any other users are also there who have liked ABC and movie, what are the next movie they have liked? Most probably you have also liked those kind of movies as well. So now IMDb will start recommending you, right? So all this recommendation we are going to now draw. So let's see this. So you must have seen that top rated movies present in IMDb part. So let's say this is one example of that. Shawshank Redemption, which is getting 9.3 rating. We have The Godfather, which is 9.2 rating. Now, let us kind of build a recommendation engine, which is going to recommend movies based on the user preferences using Apache Spark. Keep your popcorn ready with you. We are having a very interesting use case now. So what will be our requirement? Definitely we are going to work with a huge data set, because movies are not just we are going to take for a year, but we are going to take for multiple years. We are going to get input from multiple sources. Maybe you can also fetch the data from IMDb. You can fetch it from different websites. Maybe you can get from CSV. This data is also available publicly. Easy to use. It should not be very complicated. Otherwise, it will be very difficult for us to kind of work on that. And definitely, we want to have a faster processing. We don't want to kind of wait for a long time. Otherwise, we ourselves will get irritated and then we will not be able to do anything with it, right? So we don't want into that scenario. So Spark is going to let you to do all those things up. Now let's understand how our flow of this use case would be. In the end, we will also show you how to execute all these things up. But right now, let's understand this use case. So let's say if we have a huge amount of movie rating data, because we can easily get it from different websites, we will be streaming it and keeping it in our HDFS. So that's our first requirement. Because if the data is, let's say, lying in IMDb, how we will bring it to our system? We need to bring it to our system to perform any processing, right? We cannot do the processing at the site of IMDb. We have to do it at our site, maybe in HDFS or not. So we are going to perform streaming here. We are going to get the input now using Spark Streaming. Now let's do that. After that, we are going to apply our machine learning algorithm. So we are going to train the data. In training the data, we are going to use our older data set, what we have just retrieved. Based on that, we will make our model learn, make our machine learn, make our algorithm learn. Then we are going to use ALS algorithm and then generate the recommendations. Now, after we are done, we are going to fetch the results using Spark SQL. Once we have fetched the results, we are going to store it in our RDBMS system. So this is what we are going to do. Question from Rahul. Are we streaming it using Spark Streaming? Yes. In this case, we are going to use it Spark Streaming. The reason is it is going to be very faster. And Spark Streaming is best to be used in our case. If you want, it's not mandatory. You can also use other systems as well. You can also bring in Kafka also if you want to pitch in. But Spark Streaming is not only going to let us only stream the data, but if we want, we can also perform analytics. So in this case, we are going to use Spark Streaming. Second question from Nitin, train the data. Okay, let me explain what we mean by training the data. So let's say when you go to gym, what you do, like when you go first time to gym, what you do? You generally there will be a trainer who is going to kind of train you with all the exercises what he has, right? So maybe that trainer will be having a data set with him that, okay, these exercises I should start with the trainer, right? That's what happened with you. Now, whatever exercises you learn from that trainer, after you learn from him, you kind of slowly become expert and then you start trying new exercises as well, right? That's what you do in the gym part. Similarly, let's say there will be an algorithm. What that algorithm is going to do, you will be having an existing data set. Now, on that existing data set, we are going to make it learn that, let's say, if it is going to be, that data set, let's say, is assumed to be like this. Let's say if I have a column A, if I have a column B, and let's say I have a column C. Let's assume this column is salary C. Let's say here we have, let's say A is column is, let's say, age. Maybe the age of the person is 20. And let's say if he's a software engineer, okay, let's say if he's a software engineer, in that case, let's say his salary is, let's say, around 20K per month, okay. Let's say another person who is 22 years of age, and if he is also a software engineer, let's say his salary is 22K. Let's say we have this kind of data set. Maybe it's not a very good example, but just to give you an idea about it. Maybe based on this, you are trying to train the model. Means you are trying to tell to your algorithm, if my rule is this and this, that my age is this, and maybe we can add one more column of education. Now, if my education is this, age is this, so he's into this profession, he's earning this. If this is kind of rule that algorithm is going to learn. And now what is going to happen? Let's say a new rule come up for whom you do not know the salary. You should be able to predict what would be his salary. So that is what the advantage of training. So in training, you are kind of trying to make your algorithm learn if my rule is this, then the salary or maybe then the output is this. Okay, clear, Rahul? Great. Now, so are we trying to predict future results here on the past data? No, I just gave you an example here. Yes, we are going to be predicting that also. Yeah. So here we are going to generate recommendations in the end. So that would be our prediction. So what we are going to do in this example would be that, let's say if a user have liked this movie, if a user have liked this movie, if a user have liked this movie, we are going to train our model in a way that based on other users, we will be able to predict for the new user, okay, if a user is liking these movies, most likely is going to buy even like this movie as well. Okay, so here also we are going to make the prediction. Good question, Rahul. Now let's move further. What is Spark? Now let's understand this part. What is Spark here? Now in Spark, it's an open source clustering framework where all your computation is going to happen in memory. And thus Spark ensure that you are going to get a faster performance. It is built on top of MapReduce, but in MapReduce the challenge was there was lot of input-output operation. But when we talk about Apache Spark, there will be almost no input-output operation. It is going to be more of an in-memory computation, thus making it very quick in comparison to MapReduce. That's one advantage of it. You can parallelize the process, you can parallelize your data. You also have a fault tolerance, means even if you're computing in memory, you are not going to lose the data. That is one of the very good advantage in terms of Apache Spark. Now, it can support various kind of source format and it follows lazy evaluation. What do we mean by lazy evaluation? Now, since everything is gonna happen in memory, now the problem is, let's say if we are doing some operation, if we generated a block, if we keep directly in memory, it is going to unnecessarily occupy my memory. Now, let's say till the time I am not even outputting that part. Let's say I'm not printing the output, I'm not kind of giving the result to the user. Do you think it makes any sense in that case to kind of put all those blocks into memory? No, right? Because in that case, we are unnecessarily loading the memory. That's it. So till the time we are not going to hit an action. When I say action, what we mean in Apache Spark? What we mean is that we are not going to output something in Apache Spark. So till the time we do not want to, our intention is not to output the result, we are not going to keep any block in the memory for our computation. So as soon as we hit the action, then only all the previous computation is going to start. So this is called a lazy evaluation. So Spark follows that lazy evaluation. Now when we talk about Spark feature, it can be programmed with multiple languages, like you can use Scala, you can use Java, you can use Python, you can use R. This is called Polyglot. It is almost 100x times faster with Hadoop. We have just learned that because it do not do input-output processing. Thus, it's making it very fast in computation. Even the caching is very powerful here. So your disk persistence and your caching is very powerful. And your deployment you can do with Yarn, Mesos, and even it has its own standalone cluster as well. So that's the features of Apache Spark. Now let's understand our use case, how we are going to push it up. So first of all, we are going to have a huge amount of movie rating data. So let's say this will be our movie rating if we talk about from Book My Show. I hope all of you might have seen it. If not, you can quickly go and check Book My Show. It's a very famous website where you can go book the tickets, people go and rate the movies as well. So let's say from Book My Show, you can see all these ratings up. Now, so our data is going to look like this. So this is going to be our rating. Okay, this is going to be our movie rating. Now, what we are going to do, we are going to bring it to our HDFS. Okay, that's what we want to do. Now we are going to, first of all, let's see that how we are going to get our data. Now, in order to get the data, first of all, we can get it from various file formats. Now, for this system, we can get the user rating from many of the websites. Now it can be even IMDb, it can be Rotten Tomatoes. I hope you must have seen it. That's also a very famous website. We have also Times movie rating. All these data set are available in different kind of formats. Some website gives in CSV format, some website gives in text format, some website gives to database. Now this is a challenge for us, right? Now what we have to do in that case, we can either stream the data live from this website or download and store them in our local file system, or maybe we can keep it in HDFS anyway, right? So we can do all these things. So we can either stream the data or we can just download and keep it with us. There are two possibilities what we can do. So in this case, we are going to stream. So let's say by using Spark streaming, we are going to now bring the data. As you can see, we are bringing it from multiple sources. We are not just using only IMDb. We can bring it from Rotten Tomatoes. We can bring it from Times of India. So we can bring it from various sources in this case. Yes, it can deal of all this type of sources, Rahul. So in this case, so we can use Spark streaming to get all the data from multiple sources, and that's the reason Spark streaming is very powerful. Now after that, we are going to use it for real-time streaming data. Okay, so let's say we will be getting it from multiple sources. Spark streaming, if we talk about, so just to give you a little bit of brief, like Spark streaming can be used to kind of get the data from and perform your real-time streaming, and it provides you high throughput and also fault tolerant. It ensures that you are not going to lose any sort of data, because that is very crucial for us. In fact, the person name is Dana Sandhu. She mentioned that without stream processing, there is no big data and there is no Internet of Things. I hope you must have heard about these two things often, right? So IoT, big data, right? So we are working on big data, but IoT also you must have heard a lot. So without streaming, it's not even possible to generate so much of data. In fact, it's more fun when we work on the streaming of data. Okay, now let's move further. So let's understand what is collaborative. So we are going to now do a collaborative filtering. Now in this case, we are going to use machine learning. So machine learning using MLlib, we are going to do that. Now, as we just understood beforehand, we are going to train our data. Now, once we train our data, so what happens in collaborative filtering? It helps you to predict the ratings for the user for any of your particular movie based on the rating of other movies, right? So maybe if you are rating some movie, let's say if there are 4 people, Alice, Bob, Carol, and Dave. If you notice here, so let's say in this case, Alice is rating 4 here, Bob is rating 3 here. This movie, Carol is rating 5, Dave is rating 1. Similarly, other ratings also people have rated differently. Now let's say if I have some missing data, let's say if Dark Knight movie, Alice is rating 5, Bob is rating 3, Carol is rating 4, then what would be Dave would be rated? If we want to predict all that, so we can do it with the help of collaborative filtering. Okay, so that is what we can do. So let's check it up with Spark MLlib now. Now, Spark MLlib is a machine learning library in Apache Spark. So now what we can do, we are going to first of all train our data using ALS. We are going to then generate our recommendation by using this algorithm. So that is what we are going to do. So first of all, if we just remember our data set, what we have seen, maybe using that, we will see that, okay, if this user is liking this, other user is also liking this, other user is also liking this, most likely this user is also going to like this. So something of that sort, your ALS algorithm is going to take care. Even if you look from the small data, it's very easy to kind of predict in that case. But as soon as we go for a big data, then it's very difficult for us as a user to see and kind of tell that what can be a possible rating. Now in that case, ALS algorithm is going to help you to do that. And the full form is alternating least square. So that is what we are going to do here. Yeah, that's a process here. So now machine learning, what are the tools we have? We have ML algorithm, featureizations, we have pipelining, persistence, utilities. Now these are the few tools we have, like we have algorithms, we check all the features of all the things. Pipelining will be kind of chaining what we are going to create. We also want to make sure about the persistence. We are also going to have utilities here. So these are few tools which are available. Generally this kind of, all these things require the knowledge of machine learning, which we kind of teach in our Edureka sessions. But right now, just understand that yes, we are going to have algorithms, we are going to have features. Feature, if we talk about, this can be any feature. For example, if we talk about, let's say, Gmail, how it identifies that it's a spam email or not a spam email. So definitely it is checking some of the properties which we can call it also a feature here. So that's what we kind of mean by featureization. So similarly, there are a few other terms related to the machine learning here. Now we are going to fetch the results. Once we have completely trained the data, we have predict our output and all. So we are going to now fetch the result in our Spark SQL. So now using Spark SQL, we are going to get all the data in our traditional way. When I say traditional way, means in our kind of a structured format, we are going to get the output. Now Spark SQL will be used for fetching the results. Now this is also very powerful things, because here you can get all different kind of formats. So from output what you're getting, you can just use Spark SQL. Now even for Spark SQL, you can see there can be multiple data source API. Now we are going to have a data frame API, which we call it. So what happens in Spark SQL, once you keep the data, it is going to have two things, because again you are keeping it first of all in memory. Now here we will not be keeping the data like how we used to keep in our RDD. Here we are going to keep first of all a tabular kind of data, and that is going to have a column name, because we are going to have column, as well as we are going to have row information. So that is what we mean by name column. Then we are going to have interpreter and optimizer, which is going to kind of optimize your query so that we can get faster results. And then by using Spark SQL services, we are going to get our Spark SQL result. So that is what we are going to do using Spark SQL. So this will be used for fetching your results. Now, this is how your rating for movies will look like. So let's say there's a user 77. Okay, as you can see in this data set, this is user 77. So let's say we have a user 77, and let's say he is rating all these movies. So that's what we can see in our prediction as well. Now, how many total recommendations we can do for, let's say, user 77? Our ALS algorithm is going to return that we can just do it for 72. Now, these are the movies, let's say, what we are recommending. So let's say top movie recommendation for this user 77. This all we will see in our output once we execute in the program. Okay. So in the end, we will be storing all the results. So we can store it in SDFS if we want, or we can store it in RDBMS system. So in this case, we are going to store it in RDBMS. So we can now scroll it back, push it to our RDBMS system. So all the results will be stored back. So again, we can store this in a text file or in a CSV file. So anything you can do that. It's not a problem. You can also store it as a CSV file if you want. So all these results will be taken care of here. Why we were learning all this? Why we were talking about all this stuff? If you look at the job trend, in terms of job trend also, if you look at Spark job is almost thrice of any other job. Even if you compare with Hive, HBase, MapReduce, Hadoop sites, anything if we compare, you will notice this spike here. And this spike is always ever growing. It is not even coming down. It is always ever growing. And it is going to grow because Spark framework, let me tell you, is very new. It is not even old if I compare with other frameworks. So Spark is going to boom up, in fact, a lot in comparison to other. Right now itself, in fact, already outperformed all the other frameworks, and it is going to keep on happening even in future. And that is the reason Spark is one of the hottest technology right now in the market. And if you know, even with the machine learning, which we have Spark MLlib, this combination is the hottest thing currently in the market. So this is one of the job trend what we have. Okay, now let's see a use case. Okay, Avnish, I think we are done. Okay, so let's see one of the very interesting projects. It's the same thing which we have discussed with respect to our movie recommendation. So we want to also see it with respect to how we can execute it in our Eclipse framework. So let's go to our Eclipse. So this is the VM what you will be getting. Question from Amit. So we will be getting this VM from Edureka. Yes, you will be getting this VM from Edureka. Question from Anil. So this VM will be having all the things set up. Yes. Even Apache Spark, Hadoop, everything will be installed for you, including your Eclipse. Can you see here there we have an Eclipse folder? So you have to just open it directly in Executor. So you need not bother about all these things, how to execute, how to bring up. All these things will be given to you from Edureka side itself. Oh, that's awesome. Good to know that. Now let's go to our Eclipse and let's see this project. Okay. As you can see, this is a similar thing what we understood, right? We have again here we have got the data, u.data. Remember, we have talked about our data set, so it's the same data set. Now again here we are converting into case class and kind of converting to the double type and all, right? Once we have done that, then we were using the training set. Remember, MLlib will be having ALS. We're using this, we are going to train our data sets. That's what we have done in this step. Then we are going to predict the output for 789 user, let's say, right? So that is what we are doing in this step. Then we are having our recommended product, right? Same thing which we have learned right now. Then we are bringing our u.item. Now that we are loading it up. Now using this also we are doing some of part of our computation. We are kind of finding out the total number of recommended movies, right? So all these things we are doing with respect to our Spark SQL now, right? So the same thing which we have just seen. Let's execute this program. So you have to go to run as Scala application. So it will start getting executed in your console. So let me make it big. You will notice in black color the output start appearing in some time. All these queries will be started getting executed. You can see this output came up, right? For 789 user, what are the recommended movies and all. We have further queries, right? So this is also one of the output for each movies. We are defining our rating predictions and all. So similarly, right, this output will keep on coming for each of our query. These are the ratings what we are predicting in, right? So similar way, the other things, whichever query you want to keep, you can keep up, and they will be getting executed. Okay. So this is how the output will look like. So you can see the what order we got this rating and all. So this is how you will be executing your things in your Eclipse. Simple, right? Very simple to execute in our Eclipse directly and execute everything up. Okay, so this is it about this use case what we have just seen. So I hope all of you have enjoyed this session of Spark training. You got an idea about how we execute, how we can do all these things on our simple use case of movie rating. We have done a prediction on that. So I hope this might have given a good insight to all of you how the projects are being developed in Spark. All these things you will be learning in detail in Edureka Spark sessions. So all of you might already be aware that Spark is one of the hot technology, in fact the hottest technology right now running in the market in terms of jobs and all. So this is one of the booming thing, and I hope to see you all again in Edureka sessions, maybe in my sessions or maybe in some other trainer sessions. You can enroll anywhere. Edureka enroll all the word level class trainers. So you can go in any of the sessions and kind of enroll for it. It is definitely going to help you out in the career. So thank you everyone.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!